Thank you, and thank you guys for coming. One of the things I find that is a great quality of working on projects is working with someone who has made lots of mistakes in the past, because it's far faster to work with someone who's made mistakes than it is to actually make them yourself. So today I wanted to share with you some of the mistakes that we've made along the way and how we've corrected those, and hopefully you can take those home and maybe it can help you avoid some of them as well. So my name is Joel. I'm the head of data at Kik Interactive. We're a tech startup. We're a chat app, a mobile messenger with 300 million registered users. We're based in Waterloo, Ontario. We've got about 120 million in venture capital funding. Our last round came from Tencent and valued us at $1 billion. So I was just reading an article about how there are 6 people that graduated from the University of Waterloo that have founded unicorn companies, and so one of those is ours, and I'm guessing Matej may be one of those added to the list before too much longer too. He did his undergrad there. So prior to working at Kik, I spent 9 years at BlackBerry. When I was at BlackBerry, it was probably the time you guys had BlackBerry. So when you got your first BlackBerry, it's probably, I started a little before that, and when you bought your first iPhone, I left not too long after that. But their 9 years saw us grow from 3 million to 80 million users, was responsible for big data analytics, data sciences teams, client and software development, so a team of about 40 people. But then moved over to Kik, who actually is across the town from BlackBerry headquarters and has a chat app, obviously, that's similar to BBM. So if you're not familiar with Kik, it may be that you're not a teenager. Kik started in 2010 and was a chat app that was really used at a time when not all kids had phones and texting cost money. So if you rewind back to 2010, if you can remember that, it was a different world in terms of the availability of text messengers. And so for Kik, it was aspirational for kids. They could use their iPods or their iPads, and they could sign up with just a username, not with a phone number, like something like WhatsApp might have done at the time. So they were able to text with their friends. They were able to group chat after school. And it was something Kik really used to take off. In the first 22 days that Kik was available, they grew to 2 million users. So our CEO will tell you that was the fastest growing thing in the world ever at that time. So pretty astronomical. Then we ran into some problems with BlackBerry. They decided to sue Kik. It was removed from the App Store, and users went basically back down to 0. So after that, it took some time to build up those numbers again, but 300 million registered users. I realize they're not active. We don't publish our active user numbers. We only publish registered. There's a whole blog post about that if you're interested. But Kik today, we've moved into an area where we understand that teens hang out online socially as much or more than they do in real life. And that's just a different in the way that we grew up versus the way that kids grow up today. You used to be able to go out to the playground. You used to be able to hang out with your friends and not worry about your parents hearing what you're talking about. You could make mistakes your parents never knew about. But of course, with social media, whether it's Snapchat or Instagram or Facebook, there are always unintended viewers of things that you are doing, and the longevity of some of the mistakes that you make is stuck there forever. So with Kik, we've done a number of things. We only require you to use a username so you can protect your privacy a little bit more. And more recently, we've entered the world of chatbots, of bots. So if you're not familiar with bots, the way that you can think of them today is similar to the keynote earlier this morning talking about pragmatic AI that Mike was talking about. Essentially today, bots are autoresponders. There's a little bit more sophistication, but think about if you're asking Alexa about something, how when you ask her, she responds with an answer. Bots are very similar today. There's tons of potential for bots. And to me, I think of bots as the future, sort of like how software as a service maybe 10 years ago was a thing that people were like, yeah, I get that I can go to this website and I can use Microsoft Office, but I can't project that into something else. And when the word cloud came out, really it's the same thing as software as a service for the most part. But that word galvanized people and allowed people to wrap their heads around how they could use this for so many more things. So to me, bots is the new way of thinking about Internet of Things. So when you say the word Internet of Things, people in this room probably have a pretty strong grasp on it, but the general public, it's a difficult thing to wrap your head around. However, when you think about bots, if I have a thermostat bot and I have a fireplace bot and I have a garage door bot, if all of those things can talk to each other and then I can have an interface into them, now it sort of makes sense. Now I can sort of see how all of these things fit together and what a bot is and how they can improve our lives. So we launched a bot platform about a year ago. We beat Facebook to the punch by a week. We like to think our bot platform is better. It's easier to develop on. But essentially today where we're going is instead of building apps, people are building bots. So if I go to a restaurant and they want me to fill out a survey, and if I fill out that survey, I maybe get a free burger, you have to download an app or go to a website, you have to fill out a form, you have to go through a process, you have to get a link or a code, and you have to go back and redeem that. We've done some experiments with fast food chains where people go in and they scan a Kik code, immediately a bot messages them some questions with multiple choice answers, we call them suggested responses, and they're able to respond and get the results, and then they had cookies delivered immediately to them, and they thought that was pretty amazing, these high school kids that we tested this with. They almost felt like they were remote controlling the world through their phone. No friction to getting this communication with the business, and the business got way more results than they would have having to download an app. Some additional features because kids are hanging out online. The stat that we quote all the time is 1/3 of teens do not hang out with their friends outside of school in person. They hang out online. So we've built some features so kids can hang out. We've seen research that 9-year-olds to 14-year-olds with video chat, they don't call people. They turn video on, and I've got a 9-year-old son who this is a perfect example of. He's playing something, MLB The Show, with his cousin on PlayStation. He throws his FaceTime messaging on his iPad down, and they just keep it on for 3 hours, and they're chatting that whole time. It's a background activity. So we've built video chat in Kik, which we released in December, allows up to 6 people in a group to hang out together in video chat. And we've also released something recently called public groups, which is the ability for you to find communities that you're interested in and make new friends. So getting into philosophy of data at Kik, we have some fundamental principles that we believe in. We believe that at Kik, all of our employees have the right to be curious. We believe that data should be, always available and really easy for people to sink their teeth into. And like most of you, we have dashboards, we have reports, and we have a data lake where, our data team can go in and dig into things and uncover things that they're looking for. But since we're a startup, and like many of you probably know, you have to move very quickly sometimes. You don't have the luxury of designing a perfect system from the beginning. And that can come at the expense of scalable data engineering. So what our challenge is how can we compete with the big guys that are out there doing similar things to us? I mentioned Facebook launched their bot platform a week after us. But we have a small team, and we really don't have time to learn all of the sophisticated new tools that are out there. So data version 1 at Kik. When I started about 3 years ago at Kik, I went from leading a team of 40 people at BlackBerry to being a team of 1. I started with a S3 bucket filled with 800 terabytes of logs and a meeting with our CEO who said, can you tell me why people are churning on Kik by Monday? So I had a week, I had no database, we had nothing. But I had all the data in S3, and I had some pig scripts that a server developer would run once in a while to determine our monthly active users. So the first thing I did out of convenience was fire up a Redshift database. The next thing I looked at is how do I do some pre-processing on some of this data? How do I flatten it? How do I make it easier to use? So I took those pig scripts and kind of modified them a bit and was able to not give him a very good answer a week later, but was able to give him an idea of some of the things that we could start looking at. So data version 1 at Kik was very much how can we get things done extremely quickly without really thinking about design of how this was all put together. A team of 1, remember. So how it looked, we had the data in S3. We had a separate cloud provider that we ran a lot of our server systems in. So back in 2010 when we started at Kik, the AWS, believe it or not, didn't have all the features we needed. So we had logs that were flowing into S3 from another provider. We had a combination of tools. At the time it was Pig, running on EMR. Eventually we threw Spark in there as well. And then a lot of work being done in Redshift. We had Tableau Online was another thing that first week that I signed up for. And then we started using ReidAsh a little bit later. I'll talk about that more in a minute. And then eventually, as our analysts joined and our data scientists joined using things like R and Python, and then having SQL clients accessing the Redshift system. But if you look along the bottom, really we were doing, if you classify where all your data lands, our data lake really transcended all of that. And then our exploration and analysis, some of it could be done in Pig, some of it was done in Redshift. And our KPIs came from a combination of things. Some was in Tableau, some was in ReidAsh, and then other times we were grabbing things out of, R scripts or Python scripts, et cetera. So As we started to build things out, as we gathered 300 data pipelines, as our Redshift cluster was starting to break at the seams, we had to step back and decide it was time for some changes, and now start thinking about thoughtful engineering and how we can still move quickly, but build in features and changes that helped us scale. So we decided to make 8 changes, and I want to share those with you now. The first was to streamline data collection through Kinesis Firehose. So I mentioned in the past, we used another cloud provider. We had data flowing in. It was delayed up between 1 hour and 6 hours, depending on the latency in the system and the busyness and our peak hours. And then that all landed in S3. So we had to have dependencies and checking for data. Is it there? Is it there? And our reports, you never could really do real time. And then, when you were going to do a batch of the prior day's data, you had to really give it a 6-hour buffer because just in case you didn't know if that data was going to be there. So with Kinesis Firehose now, we have a new instrumentation platform. So that's something that was developed independently but was critical for what we were doing. That new instrumentation layer fires data into Kinesis Firehose and writes it directly to S3 in real time. So that gives us a lot more flexibility. It gives our developers who are using the system the ability to iterate more quickly if they're putting in newer instrumentation or testing out a feature. And then obviously it opens up the door for all sorts of streaming opportunities. The second thing we did was standardize transformations with Spark SQL. So I mentioned in the past we had this combination of all sorts of batch jobs that were running in Redshift. Again, it was sort of because how do we get the data into Redshift and then we can run SQL and get the answers. We had stuff running in Spark on EMR. We had some Python scripts and Pig as well. But transforming, it was actually after one of our data scientists came to Spark Summit last year. He came back and said, hey guys, PySpark is just SQL. And we were like, wow, that's true, let's do it. So standardizing on Spark SQL was a big game changer for us. Not only did it simplify how we could document our things and look at all of our stuff consistently, but as a hiring manager, it's a lot easier to hire somebody that has SQL skills or even teach them SQL skills than it is to look for somebody that's an expert in Pig or that knows some of the internals of Spark itself, et cetera. The third thing we did was although we hate the term data lake, we decided to build a data lake. And for us, we call it Caspian, which is the largest freshwater lake in the world that maybe you guys have named too. But for us, it used to be in Redshift, really. And we got to the point, when I started, I built a 10 terabyte database to load this data into. Now we have a 100 terabyte database, but the problem is we get 5 terabytes of new data every day. So if you're loading that atomic data into Redshift, it doesn't really make any sense. It's not worth the cost of doing that, but we do want to keep it and we never know what we're going to need it for. So we built a data lake with 3 tiers. We call them bronze, silver, and gold. So in the bronze layer, we bring in data in its raw format. There's a little bit of pre-processing that happens, but essentially you can't trust it to be perfectly clean. There are duplicates in it. The second level is silver, and in our silver layer, we've strongly typed the schemas of each of the events. So we've selected the most important events or the events developers have asked for, and we clean them and we bring them into a silver layer so you can trust an analysis that you're doing off of silver. And then in gold, this is where we combine data to make analytic data sets. So an example for us, we have a table called friendship summary. So at Kik, we don't look at your messages that you're sending. Those are private and not something that we view, but we look at the metadata around the things that you do. So we can see if I've sent a message to somebody else, how many times that's happened, how frequently, how many messages I send, et cetera, and then your social graph related to that. And based on those things, we can start to understand how our customers make new friends and why they might leave, et cetera. But in our gold layer, we have a table called friendship summary, and that combines a number of attributes about summaries about people's friendship, how many days they've chatted, when they started chatting, how they made that friendship, et cetera. So that data lake was instrumental for us because now we have a far less expensive way to capture, terabytes of data and not have to worry about, rebalancing our Redshift cluster. The fourth thing we did, and I should mention before I go into this slide, I talk a lot about Databricks. I don't work for Databricks. I'm not making any money from Databricks. I love lots of products like Sonos and Spotify and my Honda Pilot. I would talk about those equally as passionately. But for us, the move to Databricks was really a huge part of easing a lot of the pain that we had with Data V1. So for us, running big jobs on EMR, we would have a 300 node cluster running to run a job that took 3 hours. It would break. We didn't have the expertise to deep dive into all of the logs to figure out exactly why or how we fixed this problem. We took that exact same job, we moved it over to Databricks, and it just ran, and it ran in half the time. We didn't change any of the code. So for us, we don't want to be Spark contributors. We love the fact that the Databricks guys are, and there's other people out there doing it. We need to move quickly to support our business. So moving to something more managed in Spark was a huge game changer for us. The fifth thing was collaborate via notebooks. Lots of people may do this all the time, but if you remember in Data V1 at Kik, we had this challenge where, we're a small team, a couple of people on the team, and you'll find, or maybe if you have a small team, you have this tendency, like, I don't need to check anything into Git, or I don't need to centralize where I'm storing my code because it's just me. So when that's the case, you may not be doing it, and we weren't. So we had a collection of Python scripts and SQL scripts and Jupyter notebooks, et cetera, that were all consolidated with each developer. When we moved to notebooks, we made a conscious effort to design our notebook strategy so that our data pipelines, our folder structure within our notebooks in Databricks matched the same as our data lake folder structure. And then also with analysis now, it's very easy to search through other people's notebooks or collaborate on them. So for us, this was a massive game changer. Even sending links, sent a link yesterday to our executive team because they had a quick question. It's far easier to send them a link to a notebook with the results than it is, to put together a PowerPoint deck or something like that. So tied in with that is getting serious about committing code. I mentioned we had a small team. When you have a small team, for us anyway, it was a process, and any process that isn't automated is really challenging to make sure is adhered to. So we were rolling the dice, and with GitHub integration with our notebooks now, if you're familiar with Databricks, you know that you can link all your notebooks to a GitHub account, and you essentially can save revisions within Databricks, and then also obviously, commit that code to Git. So we've done that. It's worked out very well, and I can sleep much better at night now knowing that if an intern develops something really interesting, that we're not going to lose that when they leave us. Seventh, we changed our orchestration tool from data pipelines to Airflow. If you're not familiar with Airflow, it's an open source orchestration tool from Airbnb. Data pipelines in the early days gave us the ability to spin up ephemeral clusters to run a job and tear it down. It did a pretty good job of that, but was very difficult when we wanted to make jobs that were dependent on other jobs. So it is possible, but to do that with 300 different data pipelines to have interdependencies was pretty challenging. So moving over to Airflow gave us more flexibility. We've moved in that direction. There's a lot of work being done by a number of different companies in this area. So we're continuing to look and see how that evolves. But for today, Airflow gives us the flexibility to kick off jobs on Databricks and then monitor them. And when they fail, retry, and then also have interdependencies. So when 2 jobs complete, the next job can kick off. When that job completes, then 3 can spawn off of that. And then 8th, we decided to standardize our reporting on ReidAsh. So if you're not familiar with ReidAsh, it's an open source, or started off as an open source project. You can think of it as a web client, a web SQL client. And then on top of that is D3 and HighCharts and a few other open source tools. But you can write your own SQL, you can run the SQL, you can get the results, and then you have a link to that particular result set that you can just email to somebody. So I used to get a question all the time that was, not worth developing a dashboard for. It was what is the mix of male and female users on Kik, and how that changed over time. And I used to have to run the query and then send him the results. So with ReidAsh, I just write the query in there, and I just send him the link, and he can go rerun the results whenever you want. It's not quite as flashy as some of the other tools out there, but for us, it was the speed for us to deliver data back to people. And in our experience, flashy is great for board decks, but at the end of the day, the people who are making decisions actually just want the numbers. So this gets them the numbers the fastest. It's free and open source. They also have a hosted solution that I heard is really good, but something to consider and check out. It's reidash.io. So how does this all fit together for Data V2 at Kik? Well, if you recall Data V1, we had this data lake and transformation that transcended our entire stack. We had lots of exploration going on in different ways, and then we had these KPIs that were being generated through a number of different tools. So Data V2, how does this look? And this is where we landed, a much simpler, streamlined, single technology point for each of the problems that we're trying to solve. Kinesis Firehose on ingest, landing in S3. We've got Airflow for orchestration and interdependencies. We've got Databricks that Airflow fires off Databricks jobs to run our data pipelines, and those Databricks jobs land data back into S3, into our data lake. We also take that gold layer of our data lake and we load it into Redshift. So for now, we're not using Databricks as a data warehouse the way that Redshift would be used. We're finding that we're going to continue to use Redshift in the near future, but we're keeping an eye on that. And then finally, ReidAsh and other BI tools or SQL clients or people that want to do exploration that's a little more depth, they can look at Redshift. And if they're super users, they can, we've given them Databricks accounts and they can start to dig in that way. Over the next year, I suspect that will change as Databricks comes out with more features and as we evolve too. But this data lake and transformation now is pretty well contained. We've got exploration and analysis that is, a good mix of Databricks and in Redshift, and we've got KPIs that are all in one place coming out of ReidAsh. So right now we optimize, we basically load data on an hourly basis. We don't have a real need for the kind of real-time decision making at this point. I'm guessing that's going to change probably in the next 6 months. So it's really fast for us to build a new data pipeline and also build reports. I mentioned yesterday we had a question from an executive meeting. I built a notebook and shared that with them, and now I know all the results are there and repeatable if I need to. So when we added up all the work that we used to do, so we do sprint planning and we capture all the work that we're doing and we look at the effort that we're doing on data engineering and we take all the things that we used to do and we look now at where we spend our times on those old tasks, we estimate that all of those hours we used to spend have been reduced by about 70%. And here's the breakdown of where we think we get those savings. It's a little bit hand-wavy, I'll give you, but in terms of managed Spark, that's been the biggest win for us. It's the jobs don't break, or when they break, there's a reason that we get on why they broke, and then we can fix it pretty easily. We also have a good support system that we can go to and get help with. And then Spark SQL is the second biggest, which is how do we take all of these things that people have built because they're good at them, but consolidate or centralize on one technique to manage our data pipeline processing capability. So for us, what's next? The things that we're looking at, Spark is a data warehouse. It's sort of, as I explain it, as you hear it, you're probably thinking like that gold layer, if you've got everything in your gold layer, why do you even need Redshift? And we're sort of thinking the same thing. At the moment, Redshift is still really fast and really good at a lot of joins. As Spark evolves and gets some cost-based optimizations as some of the new versions come out, I suspect that will potentially come into parity. Structured streaming is something we've been working with Databricks on, we're really excited about. And our initial use case is less about kind of the real-time applications, although I suspect that won't take long after we've got it in place for people to see the benefits. But for us, it's just simplifying all of our processing up front. So being able to clean and dedupe as the data comes in. I think our perfect world, and probably for a lot of you, is if you've got these sources coming in of data that's dirty, if you can just land it and it's clean, man, that is nirvana for us. That's exactly what we want. And then the final thing is data lake cataloging. And so what we mean by that is, okay, we've got this data lake, we've got a folder structure we think makes sense, but how do people figure out what's where? So there was an interesting talk yesterday about running Elasticsearch inside of Spark and maybe how you can use that to Google your own data lake. So we're looking at opportunities for that. There's also a need, obviously, for developers to annotate data so that certain assumptions are very clear if you're using that data. So we're looking at opportunities in that area as well, of which that space is evolving pretty quickly too. So I appreciate your time. I think I've got a couple of minutes for questions, but thanks for your attention. Yes.
So how does schema migration or schema evolution work for this? It seems like you've got a lot of things tied together, so a change sounded wrong.
Yeah, schema evolution is something that we're concerned about. It sort of also depends on the time frame and the data that you're looking at. So the question was, how does schema evolution fit in with all of this? And so if you're not familiar with schema evolution, essentially it's that you can add new elements to your schema over time, and then how does Spark deal with that? Because if you have to enable features that allow you to deal with that, it can have some significant cost drawbacks. So for us, it's more about the stepwise processing between each of those layers. So our bronze to silver and silver to gold, most of those are fairly optimized to run in subcomponents, so they're daily or hourly or something like that. And it will impact us most when we get to that gold layer. If there's a new element that we need to incorporate into that gold layer, that's where we really need to understand more about the cost impacts of schema evolution. The benefit for us right now is we have these strongly typed schemas between each of these layers, or at least between bronze and silver and gold. So it's something we're thinking about, but we haven't run into yet. Yes?
You mentioned you switch from EMR to Databricks. I'm curious about, EMR has a lot more configuration. That's probably what saved you from the time involved. But it also, allows you to tune the job much deeper than maybe Databricks can do at the moment. So are your costs really not important in part in terms of ETL? Is it that reason, or is it just that the saving of time is more relevant than the tuning the performance of the job?
It's a good question. So just to summarize, the question is, EMR gives you a little more flexibility or the opportunity to have some fine-grained tuning of its controls. Was it a better idea for us to just sort of throw that aside and go towards Databricks versus being able to tweak some of those very, very detailed components? Yeah, for us it was, we didn't have the expertise to tweak those detailed components. We would rather, it's always a trade-off, like you said, about cost, but the amount of time it was taking us to debug some of these jobs, and when you're running 300 data pipelines and you have a new one or a new process that you're trying to get out of Redshift so that the database can run faster, for us it was the time spent debugging was greater than the cost of putting a little more, like sending it over to Databricks and letting it run maybe on a bigger cluster. But we haven't really seen that as been, we call it magic sauce a little bit with Databricks, where if it's the same code and it doesn't run on EMR and then you put it over in Databricks and it does run, like I don't know why it doesn't run, but I don't really care because it just works. Great. If there's any other questions, I can take them now, or I can chat after. I'll stick around for a little bit, but thanks for your time.